Good morning, everyone. Today I'm going to speak a little bit about something that relates to the automotive industry. And also CCG, something that is paramount for CCG, AI as a service. But we're going to look at first CCAM perspective, so cooperative connected automotive mobility, and how CCG could help. This is an actual work that we've been conducting through France 2030 efforts, the IPCI MECT, and and this work was also done with my colleague Ali Nader. We are going to talk about how networks evolve from vehicular networks evolve from knowledge from networks to knowledge. So, what was knowledge? Okay. So we can have a look at what knowledge was through time. So knowledge was always important in the past, from the back the House of Freedom, of Wisdom, then the Trinity College, and knowledge cost to be acquired. So if you look at how long it takes to know how to drive, 75 hours a month minimum. How to learn how to read, 3 to 10 years. Become an engineer, 25 years. How to pilot, 2 or 3 years. So these acquiring knowledge per se takes time, but as Benjamin Franklin said, investment of knowledge in knowledge always pays the best interest. So it's worth investing knowledge for our society. Now, but besides just acquiring knowledge, society also evolved into sharing that knowledge because it was important to share it, always having from scratch. We created Gutenberg printing, World Wide Web, Wikipedia, Internet of Everything. Unfortunately, also social networks to be able to share knowledge, which generalize this kind of sharing of knowledge between human beings, human area. Now, the question is, what happens about knowledge in the machine era? So there is now AI in every potential applications of in the engineering field for the last 5 to 10 years. And we could ask questions, why now we are interested in knowledge in machine era and where? So why is before knowledge was the human was at the center, and now the machines are becoming increasing more at the center. We could see before also the robotic. Before AI or knowledge was only at the decision-making process. Now AI is a lot everywhere. You can look at 6G when you're optimizing the signal network by AI, and you even have AI optimizing AIs. So that shows some very intricate implications between knowledge, generally AI. And finally, where it's before was mostly in the cloud. You had hyperscalers train AI to be able to be provided to others. But now with edge and far edge nodes, and something that is starting to be used more and more, so-called AI of things, Internet of AIs, we see that we can generate knowledge in a decentralized way, in a totally autonomous way, between far edge nodes, cars, sensors, things. So that requires also to be coordinated and understood. But Albert Einstein was mentioning that the only source of knowledge is going through experience. So you have to experience knowledge, you have to train, you need to learn to be able to get to acquire that knowledge. What we try to do is to see if we can also, from machine area, share knowledge between machines and be implanted a specific knowledge generated by another machine. Whether it is science fiction, I don't know if you can hear what you see here, but this is something, it's come from the Matrix, where you could see an example of knowledge implantation and knowledge networking.
Not yet.
So you can
Tank, I need a pilot program for a DC-12 helicopter.
Doesn't have the knowledge.
Hurry.
She will contact the operator to implant in her brain a knowledge by a specific channel. And what we sell further is that you have in the operator's computer, you have the specific types of chopper that needs to be planted. So it's not that you get a knowledge for everything, it's a dedicated knowledge for something specific that will be implanted in a human brain. Okay, this is science fiction, But now we go back to machines. And the idea would be, how can you transfer that from knowledge networking to be able to have a knowledge as a service or AI as a service? And that comes from what are the potential of doing knowledge networking on wheels. So if you look at autonomous driving vehicles, you have this monolithic paradigm where you have hundreds of hours of pre-driving. You have to drive and drive and drive. You can see what happened in the US, terabytes of training data. And the objective is that the car can know any conditions, that he had experienced any potential condition. So if you take the naturalistic analogy, it is that the autonomous driving vehicle will be born as a rocket scientist. And in the instrument impact is that the car manufacturers must basically bear the cost of the full-scale training, which has a cost. The decentralized paradigm that knowledge networking and AI as a service will bring is that you try to have a minimum autonomous driving knowledge, just as a rookie driver. And then you have on-demand knowledge acquisition. And this already exists for us as human beings. Whoever took a ice driving training. Well, usually here, no one knows how to drive on ice. But if you go to northern states, then you need to know. So in Switzerland, for example, where I'm from, then you can take special training to be able to know how to drive on ice. So that's an external training you take after that you don't need for a driver license. But the objective is to reduce the centralized development time. To distribute knowledge, the responsibility of creating the knowledge is distributed among multiple agents. And most important, to reduce the training resources that is required to train the autonomous driving. The naturalistic analogy is that the autonomous driving car, is just a freshly graduated driver. It can drive safely, slowly, inefficiently, but can get implanted dedicated knowledge to be able to know how to handle complex situation when it observes it. And if it doesn't observe that situation, it doesn't need that specific knowledge. The interesting impact is that now you can share the potential implications more than just the autonomous industry, the automotive industry. You can have road operators, city planners that can also create, share, sell potential knowledge. I'll give you an example: roundabouts, intersections. This is very complex for autonomous driving. But the city planners, they're designing the roundabout or the intersection. They could generate knowledge how to handle it efficiently, like a IKEA mounting instructions. And then the car can, the autonomous driving car that wants to go through the intersection, then can acquire that knowledge to be able to go through it in an efficient way. That would be a goal and potential benefit from road operators and not specifically the autonomous industry. So this is a typical example that we've been using or guiding our research over the years, is if you have an autonomous driving vehicle go through intersections, it will go through intersections safely. It's not about that we are going to create accidents. It's more about the fact that the car will basically be blocked because it will be hesitating. If you have a yield sign, for an autonomous driving vehicle, it's complex because every time you need to yield to it, and then you have to analyze whether you can go safely or not, and you can create congestions. What we, as human beings, are basically, we know it natively. We learn it. So by implanting a specific knowledge on how to handle a specific section efficiently, then the autonomous driving car can go efficiently and avoid traffic jams and pollutions and so on and so forth. Now the question is, what happens now if you have to navigate? First, how can we acquire that knowledge? How can we know, get the knowledge that is adapted to the specific situation and not a global knowledge, just for specific intersection, for example? How can we ensure that this knowledge is legitimate? Who created it? Can we trust it? Can we implant it like in the Matrix? Can we be sure that the knowledge for flying the chopper is the right knowledge and not something that is painted that would basically be wrong and making more bad than good? What will be the cost? What do I need to pay for it? And if I need a better quality knowledge, then do I need to pay? So these are the typical questions that arise when we start knowledge networking, AI as a service. And now, where is SIG-G in that overall vision? Well, you can see now this general architecture illustration of SIG-G from HexaX inspired by Ericsson. When you have the cloud edge infrastructures with machine learning operations, you have the SIG-G run, SIG-G core network, the management, exposure, the UE on the side, and the far edge vehicle. And on top, application domain, you're going to have the CCAM application, for example. And then on the beyond communication block, here I put AI as a service. You can also put GCAS and other aspects, but here AI as a service with the AI as a service APIs to the CCAM applications, where I'm going to basically offload sensing informations from the car to the edge cloud infrastructure to process knowledge as a service for the vehicle. That's a typical one vision for how CCAM will be integrated into a SIG-G architecture. But when we look at AI of things, when we start having intelligence and capacities, the AI of service platform for CCAM moves not to do everything in the cloud, but now use the vehicle as well, because we have ML ops in vehicles. We can do processing. We can actually not offload data, but unload data. So basically, being unloaded with the machine learning algorithms that we need to train with our sensors, but also with sensors from other cars that we receive. And then we train in the distributed way. The AI, or part of the AI, that we provide back to the architecture that is merged with other potential AI models and shared with other vehicles. The challenge, of course, here is that the machine learning update, actually, it's not really a challenge only for that, because if you look at current challenges, even in edge cloud continuum, telco clouds, we know that optimizing heterogeneous machine learning ops is challenging, but even more challenging for vehicles, because vehicles might not have all the same machine learning ops capabilities that we have in different cars. And one of the illustrations from the speaker that unfortunately lost his connections was to use, for example, GCAS to be able to do sensing instead of having expensive LiDARs or radars. So that's typical different types of sensing systems that we need to be aware to be able to unload the right models to be trained. But the challenge here is now that if we can use the vehicles and the SIG-G UE to be able to do AI as a service, we also see that we need a flexible AI as a service platform that can discover capabilities, that can use capabilities and orchestrate the AI organizations and then share knowledge. So that's the platform we developed. We call it AI of Things platform that has 3 blocks. The first is how to share knowledge. So that's a client-server architecture, IoT, compatible when you have a server storing knowledge according to a specific semantic, and AI as a service agent then connects to a specific AI actor. The actor might require knowledge. It will contact the agent. The agent will basically go to the server and see if there is a similar knowledge that is required. If the server needs power to train, it will look at all potential AI actors, the capabilities, and orchestrates according to each individual heterogeneous capacities to train that knowledge. We have 2 other blocks that are also important. The first is how to describe knowledge. And that's also what was described before about the metadata. That is part of knowledge. As every agent can train data, it can also name it the way it wants. So now how can we structure knowledge that is created by an individual entity that might not be exactly the same as another entity? So the name is different, but the model has the same objective. So we need to be able to describe it in a way that can be understood. And then we have the third block, which is semantic processing, the same way as we human beings are using semantic web technologies to be able to write something with LLMs to be able to explain what we as humans want to obtain from a machine. We will have machines that will have to explain to another machine what it wants. And the semantic processing would be to be able to understand if 2 agents, 2 knowledge with different names could actually be the same or not. So that's the first step. And the benefit of it once we plant it is to be able to create an AI as a service marketplace, where if between the interaction between the client and servers, you can split the creation of knowledge between different sellers or different, let's say, workers, and create incentives between buyers and sellers. That would basically go to these benefits of using potential vehicles as a potential trainer or a model that is either going to be used for itself or not. So this is a small example, a small demonstration that we applied our AI as a service platform for a CCAM application called virtual traffic light. So we have here, yes, this way. So you basically see here an intersection. You're going to have cars over here. There is no, purposely, there is no specific traffic lights. The system is supposed to be a stop intersections, but without any specific knowledge, the cars might not even know what to do. Cars will come this way, and they will have to decide whether they can inject into the intersections according to what other cars will do. There is two ways of virtual traffic light, progressive. The first is only it's basically non-cooperative. So the car will decide to enter without cooperating with other cars, or a cooperating strategy. This demonstration is non-cooperative strategy. So the car comes here, evaluate the danger between the different vehicles and goes. Then the question is how to evaluate the danger. How do we know if the car can basically turn depending on the speed and distance of all the other vehicles and optimize its own trajectory? So this is something that requires knowledge. If even as human beings, we have to spend years to be able to know how to safely, efficiently inject into traffic. So in that case, the car might not have it, and it will try to get it. If it gets the knowledge, then it will be able to pass, and if not, then it will not be able to pass. Let's see if I can. Okay. So then we see the first car going here. Starting this point, it will contact the 5G AI as a service architecture. I'll try to see if I can stop. So let's say that at that stage, it doesn't really matter whether the car gets access to the 6G network and gets the model, or if it gets the model and it is a wrong model. Bottom line is the car might not get the model it requires, and then it will be stuck here because it doesn't really know how to handle the traffic efficiently, and then create traffic. And you saw before that the model, the vehicles send a request to the 6G infrastructure by requiring a specific shape intersection and got the model from the 6G infrastructure. And the second part was that it could just go through. The challenge that we have here, obviously, is that would a specific model for that intersection apply to any intersection? We classify intersection with specific models that apply to all of them. That's something that is. All right. So finally, before concluding, so when we looked at the AI as a service for automotive for CCAM, we could also look at the potential as an automotive marketplace. Vehicles can train models. That's something that there is no doubt nowadays about that. The question is, it can acquire knowledge to improve its driving experience. It can use to create AIs or models for application it doesn't even need. But then it can be done for another application for another types of systems, which creates potential stakeholder community that could generate benefits of AI knowledge beyond the. But we have challenges, and that's basically where it gets complicated. We don't know how to describe model because one of the view is to harmonize completely the naming and the way we generate knowledge. AI. If every agent is going to create its own knowledge, it will name it the way it wants. Example, if it enters in roundabout, we call it a roundabout. Or someone would call it an intersection that has a round geometry. That would be totally different in terms of the name of the knowledge. We also need to uniquely describe what are the context for the knowledge. If we apply the wrong knowledge, we could see in Matrix movie, if we describe wrongly the chopper, then we'll not be able to fly correctly. And most important, if we have multiple vehicles, multiple agents training a model, we need to keep track of individual contributors, not only for the marketplace, but also for cybersecurity and trust, to be sure that the model has been. So all of this requires to create this AI as a service architecture, as I was mentioning before here, architecture that you see, this one, but also providing additional security mechanisms within the platform. So that was worth going back, sorry about that. Okay, so concluding or wrapping up, knowledge in machine area is for the same as for human societies. It will be paramount. We are going to have knowledge, AI models in everywhere. Vehicles will, edge nodes, vehicle microclouds, will all generate knowledge that has the potential to provide sustainable, constrained access to AI and machine learning. Typical aspect now that we see is called there is now a tendency of being able to generate knowledge on any kind of devices instead of having in one hyperscalers distribute knowledge creations among small entities to be able to basically become frugal. That could be one potential directions. But the challenge in that is if we have uncoordinated, untrustworthy creations of knowledge, AI, we will actually create the machine equivalent of it. That's something we would like to do. Including for the talk today, AI as a service for CCAM. This will, if we can provide an AI as a service platform for CCAM, then vehicles will be able to discover, store, acquire, share, sell knowledge they created on their vehicles in a decentralized ways. And 6G needs to be there to support it through edge cloud continuum, AI native functions, AI other things, and so on and so forth. By doing that, then we also believe that the automotive industry will benefit sharing the cost of these next-gen vehicles with the largest stakeholders I was mentioning before. And the automotive industry is not the only one that needs to train full-scale vehicles. It can train to meet a minimum level of autonomy in a specific environment, and the rest can be acquired later on demand whenever we observe or have the need. Important is to share your knowledge, because it's one way of achieving immortality. Thank you very much.
Thanks very much, Jerome. We do have a couple of minutes if you have any questions on that. I was actually struck by some of the overlap between what you were discussing there and what some of TC Data is working on. But I would be curious to get a sense from you as to how you define the knowledge here versus, for example, data. I mean, are you looking at some sort of semantic translation here in order to, for example, save on transmission of data?
That's actually a very good question, a good transition point. So for us, we use data to create knowledge. So knowledge is from process data. And typically, if I take the example of the roundabout, data would be the detections, the sensing through any kind of sensor, JCAS, red LiDARs, data, to be able to detect specific vehicles, danger situations. And then we transform that into a know-how. Know-how is to be able to know the trajectory, the heading, say the speed to be taken to be able to go through that intersection. So knowledge will be basically the know-how that we get out of observing or learning from observation. But what is interesting there is how we can describe it. And this is the problem, and this goes to the TC data, because one of the things we were confronted, we started this work a couple of years ago, and the first things that my engineer had to go through, so I knew over there, was to define semantics, because we realized that at the end of the day, there is no specific. If I want to be able to describe a model that I create by facing a specific situations, then I don't know how to name it. So I will name it according to the data I have. So I will say, I am currently naming a model roundabout safe something, because it's safe and it is efficient and it is roundabout. So I will name it this way. And then I would also have sensors that would tell me that it is an intersection, a specific shape. Then I would use it as metadata. Then that might be totally different if I do a same object in the same knowledge, which is now how to get a trajectory. If I'm a totally different situation, that is a T-shaped intersections or normal highways, then the question is, can I use the same model? How can I know that that model could be applied to another place? And first of all, we realized that semantics and ontology were lacking. It was simply nothing. So we created our own. And then we also understand that if we create our own, someone else will disagree. But then we came to the understanding that it's possible to agree on a common understanding. So we use graphs to be able to do basically semantic inference. But then we got even further by also knowing that at the end, we have AI systems to be able to structure AI models. Because part of the training was to use LLMs to be able for a specific robot to be able to describe what it needs in a natural language that will be understood then by another robot, that it is actually the same as what he has. So now it's not only humans that had to describe in natural language, but it is from the internet. But now we have a robot, as they do robots, speaking different languages that will use LLMs to understand each other. That's something that needs to be standardized in one way. But I'm very happy to see that there is a TC data in Etsy. We're also following, there's something you probably know, there was something very new in W3C. So W3C had the World of Things workgroup, and they do smart agents. So they already assume that you have AI in the agents. So you need to standardize the interface on how to describe the capacity of the agent. So that's the first step, to be able to know that car can do this or that. But what they're doing, they created months ago, is protocols to exchange LLMs, for example. So LLM is, of course, one example, but protocols, how to exchange AI models. And that's something getting very important, because that's we also standardize it. And I think for TC data, they will also.
Fantastic. Thanks, Jerome. Yeah, we do have a question here up at the back. You've got the microphone coming to you.
Jerome, nice presentation. So I live in San Francisco, and we are bombarded with self-driving cars. So I see that every day, right? And so my question is actually threefold. First, is it even realistic when you talk about LLMs are heavy in weight and downloading an LLM? I imagine just a Waymo car by my house, downloading an LLM real time, so it has to make a decision. It needs to go right or left or whatever. Is it realistic? Second part is when you talk about the marketplace, are you suggesting the marketplace are run by network operators, right? And the third part is how to ensure, we talk about chain of trust, how to ensure the integrity of those models. I don't know where they come from. Are they coming from? Where's the source? They're going to do something that nefarious, right? So that's kind of thing.
So I mean, three very important questions. So the first question, which is relate. What was again the first question? Because I kind of
the LLM, the
yes,
rate of the LLM.
So that's perfect. That's actually something that we've been doing on our 5G prototypes in our labs. These are heavy. So first of all, the assumption that it is heavy LLMs is also something we would like to move on. We could also have frugal LLMs that would be smaller, that we could change. But being able to download large AI models is a problem of 5G and 6G. 18 is currently looking at the heaviness of and having potential capacity and slices to be able to do that. So we do believe that within 5 and 6G, we will be able to download really important, heavy pieces of information, but considering the fact that it should be beneficial. It should be beneficial to the opposite. The opposite would be to download all the data and process it yourself. So the idea is obviously to be able to have a gain out of it. That would be for the first part. The second part, I think, was round back. Oh, that's very interesting. So the idea behind that, of course, we are not startup, we're just academics, but we do believe that running the marketplace could also be, it could be centralized in one way or another to be able to create a marketplace the same as Apple apps, something like that. You could have a CCAM app that you could have some improvements. I mean, typically BMW, they had already improvements to download their cars to improve comfort. So you basically buy your car and you want to, that's basically one of the vision, you buy a car and you want to have some new functions to be able to have updated comfort in the car, you can download it. This is centralized only on BMW. Now you can generalize it by CCAM entity, but obviously when we presented that work to BMW, the answer was hell no. I'm not going to implement anything to my car if I don't trust it. And I will come to the third question. But we could also have this, we could also have it all distributed. And that's a link to the third question: security, cybersecurity, and trust. So one way to look at it, and that is something that has been also investigated for years now, is to use blockchain technologies. So basically have someone that will be running a blockchain, and not any blockchain. Of course, I don't want to make the focus on specific, but Ethereum is the one we are following it because we can have smart contracts. Smart contract is exactly a training instruction. You're going to be contracted to train a specific solution, and that will be implanted inside the blockchain. So people can know who did it, in which context, because it's described in the contract, and what has been done and how much of the training has been done. And then when you get the model, you can look through the contract or through the blockchain who did what to be able to know if it is basically trustworthy. And at the end of the day, if it corresponds to what you need. I'm not saying that this is the end solution, but this is a direction that we're following to be able to provide this trust, chain trust. And coming back to the market, the blockchains are actually known also for marketplace. Because once you have your smart contract is to train, then you basically can be rewarded for what you did. So you can imagine using blockchains that someone wants to buy a model, it would pay, let's say, X amount of euros. And out of paying that, all the potential small hands who created that model would get the shares of it because it's traced in the blockchain. That's basically the way to go. Not saying that's the only one.
If I may just add to it, thank you. I love the answer. The name of my company is Blocktel, so we are the intersection of telecom. And so far, I always try to we talk about AI native in 6G. Don't you think that we should talk about blockchain native in terms of 6G? Because trust is going to be paramount in this new world where we have AI everywhere.
I do believe that within 6G, blockchain technology is going to be extremely important, especially when you're going to have dynamic. I'll take an example, edge cloud telco. When you're basically going to dynamically adapt microservices on basically piece of hyperscalers, be able to connect it to radio units, everything will be dynamic, everything will be distributed. So using blockchains to be able to secure, knows, and trace what happens is probably going to be on board. So I do believe that blockchain will be part of 6G in one way or another. Whether it will be native, this is probably not me to ask. I'm just an academic that had big dreams, but sometimes far from the reality. So I guess operators and chipset designers can have better answers. But in any case, we need to be able to go beyond centralized security and trust that we have now in 5G. In the sense that we connect over a SIM card, and we have the bidirectional trust, which was not existing in 2G, by the way, but we have the bidirectional trust. I trust the system, and the system trusts me, but I don't know now the system, how it is inside. And, using blockchain could be an
Yeah. Well, that's fascinating. I should add that were Oliver here, he'd probably note that there is definite commercialization potential. His company, Copernicus, was acquired last month by Ford, and they are looking at how to send instructions to cars that are not autonomous vehicles in order to help them be guided remotely around areas, for example, car parks or high density urban areas, so that they act almost like autonomous vehicles in themselves, which starts to overlap with things like integrated communication and sensing, for example. So I'm sorry that we don't have him here. There's obviously a lot to talk about, though, and I suggest that we do that over a coffee and then reconvene here at 11:30.